So in this episode, what we're going to do is we're going to go over inheritance. So let's just say I made a new class called Animal. And this had a function in it, a method, and it's just going to be a public method that returns void. It just says speak. And what we want it to do is console.writeLine I can speak. And then let's say we wanted, more specifically, a dog. Dog. Now, we can't, now to inherit it from animal, we do dog, animal. And then there we go. We're inheriting from animal. However, we are not inheriting speak, because speak is not virtual. And virtual basically means that anything below this class, anything that's inheriting from this class, will be able to override it. So if we do a public override, and then do speak, it instantly puts in base.speak, which is useless for us, because we don't want to have it say I can speak. We want it to say woof. So there we go. Now we have a dog that can speak. Now, let's say we wanted to inherit from that, and we want it to be inheriting from dog, and we want it to be a pit bull. Well, you might be like, well, then doesn't this need to be virtual as well, inside of dog? Well, no, because it's already virtual in its base class. So woof, we can just change to grr. So pit bulls will grr. They will growl. So let's say we want animal, A equals a new pit bull. This is entirely valid, because animal is the parent class of pit bull. So then we could just do a.speak. And if we just see, it says grr. Now, let's just say we wanted to change this to just dog. It says woof. And then animal, it says I can speak. Now you may be like, well, what's the point of this? Why would I care about this? Well, this is entirely how Unity scripting works, if you're coming here for Unity knowledge. All of their stuff extends from mono behavior, and you may have noticed this whenever you were scripting and whenever you were following along with my other tutorials. You may have noticed that every single class extended from mono behavior, and that is because mono behavior has all of the, or editor window, or so on and so forth. Now, that's great and all, but what if we wanted, let me just bring up, there we go. Now, what if I didn't want to have my animal class have any behavior? What if I'd never wanted an animal? I only wanted dogs, cats, pit bulls, etc. And actually, just to show that you can actually have multiple things inheriting from animal, I'm going to do cat extends from animal. And this is going to be public override speak. And then it's going to do console.writeLine meow. So as you can see, multiple things can inherit from animal. It doesn't error out. But let's say we never want to instantiate just an animal. We want to instantiate a dog, a cat, a pit bull, whatever. Well, we can make an abstract. And what that means is that we can't actually make these functions have any functionality, and we have to get rid of the virtual keyword and replace it with the abstract keyword. So abstract basically means we can never instantiate this. If we did animal A equals a new animal, this is entirely invalid. And as you can see, new says cannot create, well, it's off the screen, but it says cannot create an instance of the abstract class tutorial application.animal. And it's because animal cannot be instantiated. But if we said new cat, and then we did a.speak, this works. This is fine. It says meow, as you can see. That works perfectly fine. And that is a way to make abstraction. But therein lies the problem that we are not able to extend from multiple classes. If let's say I tried to have Pitbull extend from dog and cat, well, that doesn't work. That's completely invalid code. So how do I fix this? Well, I'm just going to get rid of all this, and I'm going to do interface, and you may have seen this in a previous episode, animal, and then I'm also going to have interface living, just as something. So living is going to have a property. You cannot use the public thing. So keyword. So it's going to be a float, and it's going to say, and it's going to be health. How much health does this living creature have? And we don't want other people to set it. So this is how you create a property inside of an interface. And then iAnimal is going to have speak. So to create that, it's just going to be that. Let's create the function speak. It's just void speak, open parentheses, close parentheses, semicolon. Now, well, interfaces are great and all, and we can create iAnimal a equals a new animal, iAnimal, but that's not, we can't do that. We can't just say a new iAnimal, because it's not a class. It's like an abstract class. It doesn't physically exist. It can't be created. It doesn't have any properties. It doesn't have any state in it. So what we can instead do is we can do a class, living animal is what I'm just going to call this, and it extends from iAnimal, comma, iLiving. So now, if you're following along with me, you may be seeing this underline. I don't know if this will appear if you don't have ReSharper. I believe it does, though. But if I let ReSharper implement members, and there is a way, but I don't remember for Visual Studio to do it. Actually, hold on. I think if you right-click and then do implement interface explicitly, or implement interface, but that makes it all messy, and I don't want that. So I'm just going to do read the ReSharper way, and as you can see, it pops up with this window if you do it the ReSharper way. And so I want it to implement the members from iAnimal and iLiving, and I want the properties as automatic property. So, and then I'm just going to click finish. And as you can see, what it does for me is it does public float health, and then it creates a private setter, which is great and all. And it also creates a speak. And what we're going to do is speak equals is right line. I am a living animal, and I have health. And then we're going to do the health property. And what I'm going to do is I'm going to create a public constructor. And it's going to take in float h health, and then health equals health. And so then what I'm going to do is I'm going to, so where I have iAnimal, a equals living animal, sorry, new living animal, and then I need I need some health, so I'm going to give it 10 health, 10.5 to show that it is actually a float, or 10.4f, that works, and then I'm just going to do a.speak. So if we run it, I am an animal, I'm a living animal with 10.4 health. So as you can see, it is using iAnimal and iLiving. Now, what's great about this is that we can abstract things into multiple different. We can abstract functionality and stateful information into multiple different things. So that, for instance, let's say we only wanted like a window. We wanted a window and or let's say we wanted an iGame object, and then we also wanted an iRenderable. Now, an iGame object only holds position information. So, iGame object. It only holds float array, or better yet, IEnumerable float. And as you can see, that's the interface as well. Oh, and your colors might not be the same as mine. I changed my colors to be these colors, the pink for the interfaces, because it helps me. So IEnumerable float, and then we're just going to call it positional information, or better yet, just position. Get set, and then an IEnumerable type float for rotation, and I'm just going to do it once more for scale. So let's say our iGame object holds that kind of information, position, rotation, and scale, but our iRenderable, oh, and it also has a function, void update, decimal elapsed time. And by the way, decimal, okay, so float is the least precise of the decimal operators. Then there's double, which is more precise, and then decimal, which is the most precise. I'm going to go with decimal here for elapsed time. Double or float could probably be perfectly fine. But and then I'm going to have an iRenderable, and then this is going to just have the void function of render. And what we're going to do is we're going to create a class that we're going to call empty game object is what we're going to call it. Empty game object. And then we're going to have it extend, well, no, not extend, implement the interface iGame object as well as the interface iRenderable. And then I'm just going to let ReSharper implement the members and have it do automatic properties. And for the update method, I'm just going to say position sub 0 plus equals 3. Okay, yeah, because we're using IEnumerables dot at element at 0. So position dot element at 0. Okay, that's the problem with using IEnumerables. We're going to instead use a float array. Because it's much easier. To work with. Now I'm just going to get rid of this and implement those members as automatic properties. And on update, position sub 0 plus equals 3. Rotation sub 1 plus equals 0.25 f, and then scale sub 0 plus equals 5. And of course these would be vector 3 objects if we had vector 3 objects, but I don't have them. And then for the render, I'm just going to do console.write line, well, better yet, Okay, so for each console.writeLine f. Actually, I could have. I'm so indecisive. Console.writeLine, and I'm going to show you string.join. And this is going to join using new line. Join using new lines. No, actually, sorry. I'm going to use string.format here first. Zero, new line, 1, new line, 2. And then where we're going to pass in position, rotation, scale, and then we're going to do comma. I'm just going to hop down to the next line. String.join. Using commas, I'm going to join the positions. Oh wait, hold on, I did this wrong. I meant to do string.join here. Not sting. String.join here. Using commas, position. And I'm just going to copy and paste this into where I put rotation and scale. After I drop these down onto new lines, because it's nicer and cleaner and better to do it that way, because it's easier to read. So if I then create an iRenderable, or well, actually an iGameObject, go equals a new empty GameObject, and I'm actually going to create a constructor, public empty GameObject, and then I'm just going to call these P, R, and S. So what I'm doing here is I'm going to pass in an IEnumerable of float, just so that I can pass in like lists or whatever I want into here, and it's going to instantly turn into arrays. So position equals P, rotation equals R, and then scale equals S, and after P I'm going to do .to array, and I'm going to put that at the end of each one. And what that'll allow me to do is then pass in a new array, and I'm going to pass in an array even though I made it to where I can pass in anything I want. So I'm just going to pass in a new array of 1, 3, and 5. New array of 30, no, of 0, 0, 0, 0, because that's like a quaternion, which is what is used in Unity. So, and then scale is going to be 1, 1, 1. And it seems to be seems to not be liking this. Oh. I think this is being IEnumerator. No. Should be IEnumerable. Get enumerator. No. That's weird. It should be working. An int array is not assignable to parameter type IEnumerable type float. Oh. If I just do F on each one of these, there we go. yeah, you can't assign. It's not going to do implicit assigning like that. You actually have to say you want these to be floats. So I just put an F at the end of each one. So then if we do go, then while true, go.update, and since we know it's an iGame object, we know it has the update functionality. Let's just put in 30. And then since, but we don't know that it has the render functionality. So what we can actually do is we can just say empty game object, and bam, we know that it has, or better yet, var, which I always recommend you use rather than implicit typing. Just use var, and it will pick the type based on the empty game object. So I'm just going to put the console.read key inside of here. So this is an infinite loop. So what it's going to do is update, and it doesn't really matter what you type in here, and then it's going to render out. So if I just run it, here's the first update. So as you can see, 435 is the location. And actually, I'm going to make this easier to read. So it updated once, and better yet, even better, position, rotation, scale. There we go. So it updated once already, so that's why these values are at different values than what we called. So if we want to fix that, what we can do is we can call update after render, but that's not actually recommended. So I'm not going to do that. I'm not going to worry about it. So these are already being updated. So as you can see, it's already at 0.25. So if I just typed in a new character, say it's being updated again, updated, updated, and this allows us to package functionality. So for instance, if we only wanted renderable objects that did not have this positional information, or was not able to update, we can just extend from iRenderable, or objects that could not render but had the positional information and could update. And we could have many other things that we want in there, and it did that, and it handled that. And so yeah, that is interfaces as well as inheritance in this episode. And that's really it for this tutorial series. And in the next tutorial series, we'll be